All right, so to show that any two polygons are similar just by using the definition of similar, we would have to show that all pairs of corresponding angles are congruent. So for example, with these two triangles, I'd have to show like the red and the red, green, green, blue, blue, all three are congruent, and that all pairs of corresponding sides are proportional. So like 2 to 4 is doubling, 5 to 10 is doubling, and 7 to 14 is doubling. So if all side lengths grow by the same scale factor or multiplier, that would be showing that they're proportional. So that is the full definition of similarity. However, with triangles, we are able to get by with less than that. So there are 3 different postulates or like shortcuts that we can have limited or less information, and by other proofs know that it forces all the other information to also be true. Like there's no other option. So the first one is if I only know 2 of the angles, I don't know the third, that is enough to prove or say that the triangles are similar, because that's going to force that third angle to have to be the same. It's also going to force my corresponding sides to have to be proportional. So just having 2 angles, and so we call it the angle similarity postulate. And to prove that or justify that, so here we would say like angle R and angle L are congruent, and angle T and angle P are congruent. So that's enough to satisfy that both triangles are similar, and so our similarity statement is writing this right here. So triangle TRS, so TRS is similar. We use that little tilde to say is similar to triangle PLM, and again making sure that we're writing our letters in the corresponding order. So angle T corresponds to angle P, so they're both written first. R to L, they're written second, and then S to M, and they're written third. And then, so that'd be the first part of our similarity statement. The second part would be the reason why. So this would be by angle similarity. So when you're writing a similarity statement, this would be all we're looking for. So that's one shortcut, is just knowing 2 angles are congruent. We can assume the rest is also going to fall into place, the rest of this definition up here. The second one is if I have 1 angle that's congruent and then 2 sides on either side of that angle that are proportional. So this is called side angle side. And to justify that, I would need to show there's a congruent pair of angles. So A and Q. So angle A is congruent to angle Q. And then I need to show 2 sets of proportional sides. And so what that means is that if I look at the reduced ratio of like the corresponding sides, like 8 and 12, compared to the reduced ratio 6 to 9, they should reduce to the same value. That's how I show they're proportional. So 8 over 12 reduces to 2/3. And so we want to make sure we're being consistent in the order we're going. So 8 over 12 and then 6 over 9. Make sure you're not doing 8 over 12 and then 9 over 6. Those would not be accurate to compare. So 6 over 9 also reduces to 2/3. So since the 2 pairs of corresponding sides, if they reduce to equal ratios, that's what proportionate means. Proportionate. That's how we like show or justify the side part of this, is if they're the same, and then the angles are the same. So then our similarity statement would be that triangle ABC is similar to triangle QRS by side angle side similarity. And then just a side note with this similarity theorem, it does matter where the angle is in relation to the two side pairs you're looking at, so the angle has to be in between. So something that we cannot do is if I had a triangle that had this angle, and then we'll say this side, and those sides were known. So since this angle is not between the two sides, this is not a postulate we can use. If I only know this, that does not show that the two triangles be similar if there's a second triangle here. So like the SAS is kind of going in order, so like side, angle, side, like around the triangle. This here would be like side, side, angle, so it's a different order. So that's not a similarity postulate. So be careful about the positioning of the angle to the sides that you're comparing. And then our last one is side, side, side. So if I don't know anything about angle measures for my two triangles, but I am able to compare all three pairs of side lengths, and I can prove that all three pairs of side lengths reduce to the same ratio, just like we showed here, but with all three sides, that would be enough to justify that the angles will also be equivalent and these triangles would be similar. So this one we'd have side, 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 and then I would show, so 8/12 is 2/3, and then 6/9 is 2/3, and oops, it's purple. 5/7.5 is also going to reduce to 2/3. So since these are all equivalent reduced ratios, then we would make our statement that these two triangles are similar by the side, side, side similarity postulate. Okay, so then the way we would use this is we would be looking for, I'm going to just jot those down, so we have angle, angle, side, and side, side, side. I'd be looking for evidence of any of these three in order to prove my two triangles are similar. If I don't have enough information or one of these I can't prove, then they're not similar. So for this first triangle, we are given here a side, angle, side, but in this triangle we are given two sides, but the angle is not the corresponding angle to this right here. We don't know what this angle would be that would correspond to the 70 degrees, so we actually do not have enough information to determine if these triangles are similar. So we can't really say yes or no, but not enough info. We would have to know this angle right here. The second one, so we are using a previous fact that if I have all three sides congruent, these are both equilateral triangles, and that means in an equilateral triangle, all angles are also equal, so these are all 60-degree angles, and that's going to be true for this triangle as well, because it's also equilateral. So having all angles be the same actually is surpassing the information we need for angle, angle. We could also do, like if we know, like if this length was side A, all three would be a length A, whatever that is. And then if that was B, all would be B. So my corresponding pairs would all be the fraction A/B. And so those would obviously be proportionate to each other because they're identical to each other. Then we would actually meet this entire criteria. So we've met all of them. So these are for sure similar. So these are similar. And then our statement would be triangle QE U is similar to triangle SIO. And then we could pick any of them. I'll just pick angle, angle, but any of the three would prove that these are similar. All right, this third one, so we don't have any angles, but we are given side lengths for all three sides of each triangle. So we are going to look at what the reduced ratios are for each pair and see if they match. So 8/4 is 2. 10/5 is also 2. And then 13/6. So all we care is that it's not 2. So if not all three are proportional, these are not going to be similar. And then this last one, so we are given this angle here, 30 degrees and 30 degrees there. We are also given this right angle, so we know those are the same. So if I look at my list, angle, angle, I have two angles that are congruent to each other, so that's enough information to say the two triangles are similar. And then we do want to still make sure our naming goes in the right order. So I know that that side and that side, the coloring can help us write that order. So like angle A here, if I do ABC, is similar. So the angle that corresponds with A is Z. So it starts with Z. And then A goes to B, and that corresponds with Y. Z goes to Y. And then my last angle was X. And that one was by the angle, angle postulate. So even though we were given one side, that wasn't necessary for proving the similarity there. So then now we're going to look at if I am given that the triangles are similar. So given they're similar, we are allowed to assume all of this information up here by the definition of similar. So all angles, corresponding angles are congruent. All pairs of corresponding sides are proportional. So we want to make sure we're matching things up so we can look here at those angles. So this is also a previous idea. So vertical angles are congruent to each other. So then that helps us set up our corresponding sides. So like between the right angle and the pink angle, right angle and pink angle. So the 12 and X are going to correspond to each other. And then the 14 and the 42, the other legs of those right triangles, will correspond to each other. So because we were given that these are similar, we know that the corresponding sides are proportional. So I can set up a proportion. So I'll do 14/42 and then stay consistent. So if I did 14 in the numerator, I have to do 12 in this numerator. And then over X. And then we can cross multiply. So 14 times X equals 12 times 42. So 14X equals, hold on, 504 divided by 14. So X is going to be 36. And then I could plug that back in there and check, or plug it back here to check that these both reduce to the same fraction. For this triangle, so we are looking at this smaller triangle being similar to this larger triangle. So I'd recommend drawing the two triangles separately as a easier visual to work with. So 12, 15, and 17 is that smaller top triangle. And then the bottom triangle, so this edge here is 12 summed up with 8, so it's going to be a total of 20. So 12 plus 8, so that's a length of 20. And then likewise, 15 and 10 makes this a length of 25. And then we have x on the bottom. And I can match up. Those will be corresponding. These will be corresponding. And these will be corresponding. And then I can use, so I for sure need to write a ratio of my, including my unknowns, so I'm gonna need 17 and x. And then I can either use the 15 and 25 to compare it with, or the 12 and 20. They will both reduce the same thing, so it doesn't matter. I will use the 15 and 25. So then I have, when I cross multiply, I'll have 17 times 25 equals 15 over x. And then 17 times 25 is 425. And again, if you would use the other proportion or set up a little differently, it should all come out the same at the end there. So x is 28.33, and I should be able to, again, plug that back in to check my work. So these last two I am going to post in a second video.